All right, so let's get into the substitution method, picking up from the elimination method, right? That's what we did prior. All right, so the substitution method is just like the name, right? Substitution. So we're going to sub in one of the variables. So we need to solve for either x or y, whatever is most convenient. That's what we're going to solve for. So we pick a function. Typically, you pick the easy one, right? Usually one that has a single variable. So here we have any one of these to choose from. These would be the ideal ones. I'm going to pick, it really doesn't matter which one you pick. Now, you can pick any variable, but you always want to just be nice to yourself, right? I'm going to solve for this variable right here, right? It's by itself already, and it's positive. That's what I look at. So I'm going to add y to both sides to isolate the variable that I want. So right now, x is equal to -2 plus y. Okay, here's the deal. Now that we solve for one variable, we're going to sub that variable in to the other equation. That's the key. You have to sub it into the other equation. You can't sub it in to the one that you just solved. Otherwise, it's not going to work out. So what I'm saying is, if we do 3, I want to use red or green. 3 times x, but we know that x is -2 plus y. Minus y equals 0. Right? All we did was sub in x into the other equation. So right here. Hopefully you can see that. Now we just solve for y. Start simplifying. So this is going to be, 3 times -2. So it's -6. 3 times y plus 3y minus y is equal to 0. Okay, solve for y. Combine like terms. This is going to be -6. 3 minus 1 is 2 equals 0. Still solving for y. Plus 6 plus 6. We get 2y is equal to 6. Divide both sides by 2 because we're trying to isolate y. Y is equal, 6 divided by 2 is 3. So right now, y is equal to 3. Okay, we have to figure out what x is. So we plug that back in. Where do we plug it in is a question. Well, here, x is already by itself. That's the guy I'm going to use. Typically, when you plug it back in, you can plug it into the original, or you can plug it into where x is already isolated. I'd plug here. Or actually, it's not x, it's plug in y. So we solved for y. Plug in y. All right. This is going to be x is equal, that's nice, -2 plus y is 3. So -2 plus 3, positive 1. So x is equal to 1. And our solution, one solution, 1 comma 3. Right, one solution. Right. Let's see another example. Again, substitution method. Solving for x or y. So right away, this jumps, like one of these jumps out at you, should, right? This guy right here. The y is already isolated, so that's going to be my target. So if I minus 3y from both, or minus 3x, I'm sorry, from both sides, minus 3x, we get that y is equal to negative 2 minus 3x. All right, there's my substitution. Now I got to take it and plug it back in to the other equation. Never plug it into the same one. Right, this guy is going to plug in right here. So we get 6x plus 2y. In this case, y is going to be negative 2 minus 3x equals 10. Okay, we start simplifying, solving for x. Notice how, like, after the substitution, the y's went away. All we have are x's. That's what we want. So when we distribute, we get 6x plus 2 times negative 2. It's going to be negative 4. That just looks weird that I did that. You could just say minus 4. Right, that's the same as negative 4. 2 times negative 3, so negative 6x equals 10. All right, combine like terms. Okay, so some weird things are happening. We have a 6x minus 4 minus 6x. So 6x minus 6x, those cancel. And then we have negative 4 is equal to 10. So this is crazy, but to follow what we did in the previous section, like with the notes, right? Like here, I'm taking advantage of this right here. Anytime we get zeros equal to a number. So what I'm going to do is I'm going to add 4. It's kind of unnecessary, but just so you can see, stay consistent with the notes. We have 0 equals a number. 0 equals a number. This is bad. This is no solution. Really, right here when we said that negative 4 is equal to 10, so this right here is good enough to know that, okay, negative 4, how does that equal 10? Right, that's nonsense, right? That doesn't even make sense. Negative 4 equals negative 4 and only negative 4. Here you could have said no solution, but to stay consistent with the notes the way I showed you earlier, 0 equals a number. This is no solution. No solution. All right. Last example. So here we have, oops, bro. All right. This one's not as easy, right? Because there's nothing obvious. So I just pick a random one. I'm going to be nice to myself, and I'm going to pick 4x. Just, it's the first one in line. That's the one I'm going to solve for. So if we add 6y to both sides, we're going to get 4x equals 8 plus 6y. Isolating the x, if we divide everything by 4, we're going to get cancels on the left. X equals 8 divided by 4 is 2, plus 6 divided by 4, half of 6 is 3, half of 4 is 2. So here we have x is equal to 2 plus 3 halves y. Okay, we've isolated it. We have to plug it in somewhere. We plug it into the other equation. So it's going to go here appropriately. So this is going to be 6x. In this case, x is this thing. 2 plus 3 halves y minus 9y equals 12. Okay, all the x's are gone. We're left with nothing but y's. Let's do this. So we distribute 6 times 2, 12. Okay, 6 times 3 halves. All right, we can do some side work if we can't do it mentally. So 6 times 3 halves. So all whole numbers are over 1. 6 times 3 is 18. 2 times 1 is 2. 18 divided by 2, we should know that this is 9. So plus 9y. Minus 9y, that's convenient, equals 12. Okay, here we have combining like terms. 9y minus 9y, those are going to cancel. So really we're left with 12 equals 12. Okay, if we want to stay consistent with the notes, for the elimination method, we ran into a situation where it was like 0 is equal to 0. Well, that's true. However, it's also true if the number equals the same number. Right, here we have 12 is equal to 12. This is basically the same thing as 0 equals 0, right? Like whatever the number is on the left, that's what the number is on the right. So this is going to be infinite solutions. So those are our cases. Those are our 3 cases. One solution, no solution, and infinitely many solutions. All right. What we got left? Word problem. All right, so Kim purchased a total of 30 mugs and keychains from the store. Each mug costs $6 each. Each keychain costs $2 each. How many mugs and keychains were bought if she paid $120 in total? All right, so we set up 2 systems of equations and then solve it by using either method that we just went over. Okay, so the hardest part about this problem is that there aren't any equations and we have to come up with our own equations. So a good tip is that we're going to have one equation. So where can we make some notes? We're going to have one equation in terms of items. Right, some equation that talks about the items that are purchased. And then we have one equation in terms of money or cost. Right, because in the equation or in the problem, it talks about mugs and keychains, and then it talks about the money that is involved. So, what are our variables? We need 2 variables, x and y. So, if we let the mugs be x and the keychains be y. Right, that's really all that I can think of to make the variables, right? One for mugs, one for keychains. So she bought a total of 30 keychains. So what this is saying is, you take the number of mugs plus the number of keychains, this should equal a total of 30. So there's my one equation in terms of the items, right? You add the items together, equals the total amount of items. X plus y equals 30. All right, the second equation, which is going to be in terms of cost. I'm going to change the color. All right. It says that each mug costs $6. So this is 6x. Right. If I bought 1 mug, $6. If I bought 2 mugs, 2 times 6. If I bought 3 mugs, 3 times 6. So the number of mugs you bought times $6. That's the total cost of the mugs collectively. And then the keychain costs $2. So similarly, this is not X. This is 2Y, right? Because if keychains are Y, then it's $2 times the number of keychains. Okay, the total number she paid was $120 in total, right? $120 in total. So the second equation is going to be 6X, the total cost of mugs, plus 2Y, total cost of keychains, and then the total price itself, $120. And there's our, what's it called? Two equations, our system. This is our system of equations. So now we can use either method, the elimination method or the substitution method. To stay consistent with the video, we'll do substitution method, applying what we just learned moments ago. So I'm going to solve for a variable. We'll pick a random one. This one looks good, solving for y. So if I subtract x from both sides, I'm going to get y is equal to minus x plus 30. Right? All I did was subtract x from both sides of the equation. And then I'm going to plug in to the other equation. So we're going to get 6x plus 2y. In this case, y is going to be negative x plus 30, which is equal to 120. And we distribute because all the y's are gone. We have nothing but x's. So we're going to distribute this is going to be 6x minus 2x, right? Because 2 times negative x is negative 2x. 2 times 30, 60 equals 120. Okay. Solving and combining. So we can combine 6 and 2, negative 2. 6 minus 2 is 4x. I'm going to subtract 60. So 120 minus 60 is 60. All right, off to the side here. This is going to be 4x. I'm just cleaning it up. 60. Okay, when I divide to solve for x, 60 divided by 4. So x is equal 60 divided by 4. Let's see. Half of 60 is 30. Half of 4 is 2. 30 over 2. 30 over 2. 15. So 4 goes into 60 15 times. So x equals 15. Think about what we just found. In terms of this problem, that's 15 mugs. So now we got to figure out how many keychains they bought. So let's plug in x. So here's x, here's x. You can plug it into either one. It really doesn't matter. The original one would have worked it also, right? 15 plus y equals 30. I mean, it doesn't matter which one you do. Pick the easiest one, right? So if I say y is equal to negative 15, right? Because it's negative x, negative 15 plus 30. Okay. 30 minus 15 is 15. So 15 keychains. Okay. Hopefully this helps you guys out. Catch you guys in the next video. Peace.